Let us see 4th semester CSE and ECE students how to find moment generating function mean and variance of Poisson distribution. The probability density function of Poisson distribution is P of x equal to x, which is equal to e power minus lambda power x by x factorial. Here x takes the values from 0, 1, 2 etc. up to infinity. But in binomial distribution, x takes the values from 0 to n. We know the starting and the ending limits. But in Poisson distribution, it starts from 0 and it goes on up to infinity. Now we are going to see how to find the moment generating function mean and variance of Poisson distribution. The moment generating function mx of t equal to summation e power tx into p of x. In the p of x place, we are going to substitute Poisson distribution formula and the starting and ending limits. So, summation x equal to 0 to infinity e power tx. In p of x, we are going to substitute the probability density function of Poisson formula e power minus lambda power x by x factorial. Here, e power minus lambda is constant. So, we are taking that e power minus lambda outside. E power minus lambda into summation x equal to 0 to infinity. The power in e power tx and lambda power x is common. So, I am going to take the power commonly outside and we can write it as lambda into e power t whole power x by x factorial. In the next step, keeping e power minus lambda as constant, we are going to substitute the values of x from 0 to infinity. First, I am going to substitute x equal to 0. If we substitute x equal to 0, lambda into e power t whole power 0. That is, any number power 0 is 1. Likewise, 0 factorial is also 1. So, we can write it as 1 plus. Instead of x place, we are going to substitute 1. Lambda into e power t whole power 1 by 1 factorial plus. Instead of x, we are going to substitute 2. Lambda into e power t whole square by 2 factorial plus etc. It goes on. So, it can be written as 1 plus x by 1 factorial plus x square by 2 factorial plus etc. equal to e power x. This is the formula which we had studied in 10th standard. We are going to compare this formula with the above equation. In the place of x, there we got lambda into e power t. X place la lambda e power t irukku. So, we have to substitute, instead of x, we are going to substitute lambda into e power t. Now, the formula can be simplified as e power minus lambda into e power lambda e power t. Since x is equal to lambda into e power t. Again, we can simplify as both the base are same e and the pass lambda is common. So, we can take e power lambda outside. E power lambda into e power t minus 1. We can take it as first equation. Since this is the moment generating function of Poisson distribution. Next, we have to find mean. Mean is the first derivative, which the first equation can be differentiated with respect to t. So, we are going to differentiate this with respect to t. Mx of t, if we differentiate, we will get mx dash of t. In the right side, whole function can be written as capital X. So, e power x, if we differentiate, we will get e power x. So, whole term is written as it is. Again, we have to differentiate the power of t term, lambda into e power t. If we differentiate lambda into e power t, we will get lambda is constant. Differentiation of e power t is e power t. Now, we got the differentiated term. We can take it as second equation. We have to substitute t equal to 0. Next one, I am going to substitute t equal to 0. Mx dash of 0 equal to, where there is t, we have to substitute 0. We know that e power 0 is 1. I had substituted t equal to 0. In the power term, e power 0 equal to 1. Again 1 minus 1 is 0. The whole term is simplified as 1. Only the lambda will be available. Now we got the mean. Mean equal to lambda. This is the first derivative. Second one, we have to find variance. Again, we have to differentiate the second equation with respect to t. But before differentiating, we have to see there are two t terms, e power 1 t term and lambda into e power t term. So, we can differentiate in the form of uv method. Now, the blue line is taken as u and the green line is taken as v. uv formula, u into v dash plus v into u dash. Now, we are going to differentiate with respect to t. If we differentiate mx dash of t, we will get mx double dash of t. mx dash of t differentiate panna mx double dash of t கிடைக்கும். Lambda is constant. We had taken that lambda outside. Keeping u as constant. U term alla constant வச்சிட்டோம். We are differentiating e power t. e power t if we differentiate, the answer is e power t plus v into v is e power t. So e power t into, if we differentiate u, that is whole term is again treated as x, e power x term. Power of e power t, again we have to differentiate. If we differentiate, we will get lambda into e power t. The next step is, where there is t, we have to substitute 0. Instead of t, we are substituting 0. Again, if we simplify, we will get lambda is constant. All the term will become e power 0, that is equal to 1 plus lambda. We remove the bracket, lambda plus lambda square, that is the second derivative. We want only variance. Variance of x equal to mx double dash of 0 minus mx dash of 0 the whole square, that is second derivative minus mean square. The second derivative answer is lambda plus lambda square minus mean answer lambda the whole square. Lambda square cancels. Now we got the variance. Variance is equal to lambda. Only in the Poisson distribution